Today we'll be presenting our project on our analysis of an automobile dataset from the UCI machine learning repository. Cars are more than just transportation. They represent engineering choices, consumer priorities, and market trends. That's why analyzing automobile data gives us such a powerful lens into how design and performance shape value. Our goal was to understand how key vehicle attributes influence pricing and market positioning within this dataset. The dataset we worked with includes 205 cars from the 1980s with 26 different variables. After cleaning and organizing the data into a format that's easy to analyze and understand, we focused on how price is related to several important features, including, but not limited to, horsepower, engine size, curb weight, fuel efficiency, and body style. To explore these relationships, we used visualizations and multiple regression models. This allowed us to identify the main drivers of price across the dataset. Beyond just price prediction, we also compared these automobile attributes using two ratio-based metrics. Fuel efficiency for cost, which highlights how much value customers get in terms of miles per gallon relative to price, and performance for cost, which measures horsepower output relative to price. These comparisons helped us see which automobile attributes delivered the best balance of efficiency and performance for their price. Building on this analysis, our study forecast how these automobile attributes shape vehicle pricing and market positioning. By applying multiple regression and ratio-based analyses, we can predict which brands are more likely to dominate specific price tiers and body style categories. For example, efficiency to cost and performance to cost metrics reveal which attributes are poised to deliver the strongest value in fuel economy and horsepower. This is especially important when considering consumer trade-offs between design, efficiency, and performance. Ultimately, our findings anticipate broader trends in the automotive sector. They show design choices, engineering decisions, and efficiency standards. They show how design choices, engineering decisions, and efficiency standards interact to drive both consumer preferences and market outcomes. In other words, the way cars are built, whether emphasizing horsepower, fuel economy, or body style, directly shapes how they compete in the marketplace. Overall, our project demonstrates how statistical modeling and ratio-based comparisons can provide insight into automobile pricing and positioning. By analyzing attributes like horsepower, engine size, and fuel efficiency, we can better understand not only what drives price, but also which automobile attributes deliver the best value.
So for this part, I will walk through the dataset we used, the key feature in it, and what we discovered from our initial analysis. So our project uses the automobile dataset from UCLI machine learning repository. This dataset is widely used for research and teaching, and our description is based on the official documentation provided by UCI. Here is the source link to the original dataset. So the overview, the dataset contains 205 cars and 25 attributes, and each row represents a different vehicle. These attributes include a wide range of characteristics such as car make, body style, engine size, horsepower, fuel type, drive wheels, fuel economy, carb weight, and the vehicle's price. So we have everything from basic specification to performance features and market price. This makes the dataset ideal for exploring what factors influence the price of a car. So before building any models, we explored the data to understand its basic structure. Here are the key insights. The average price of the cars is around 13 grants, and price range from 5 grants up to 45 grants, showing a mix of economy cars and higher end models. The average engine size is about 126 cubic inches, which tells us most cars sit in a mid range with both small and large engines included. Horsepower ranges widely from 48 to 288, showing a spread from low-power commuter cars to more powerful premium vehicles. We also have several body styles, such as sedans, wagons, hardtops, and convertibles. Drive type include front-wheel, rear-wheel, and four-wheel drive, which is important for our understanding performance and pricing differences. Finally, the dataset contains cars from 22 different manufacturers, including BMW, Toyota, Honda, Porsche, and others. This gives us us good this gives us good diversity across brands and price tiers. Next, we looked at how different numerical variables relate to price. We found that price has strong positive relationships with engine size, horsepower, and curb weight. This means that cars with bigger engines, higher power, and heavier bodies tend to be more expensive, which matches real world expectations. On the other hand, we found a negative relationship between price and fuel efficiency, which measure using city and highway MPG. This means that cars with higher fuel economy, like compact or economy cars, are usually cheaper. So these cars, so there is a clear trade-off between power and efficiency. Putting all of this together, our preliminary conclusion is that performance-related characteristics, engine size, horsepower, and carb weight, are the strongest predictors of vehicle price. These features all increase with price. Meanwhile, fuel efficiency goes in the opposite direction. As MPG increases, price tends to decrease. These insights help guide the modeling phase of our project.
Hello, my name is Mihail, and my contribution to the project was preparing the dataset. I was responsible for finding the original source file, cleaning the data in R, creating the tidy datasets, and producing exploratory visualizations with regression lines. For our project, we worked with automobile dataset from the UCI machine learning repository. It contains 205 rows and 26 variables, describing technical and price information for cars, including horsepower, engine size, fuel type, body style, and price. This dataset allowed us to explore how car characteristics influence market value. To clean the dataset, I created a Quattro document in RStudio. First, I imported the data directly from the original zip file. I replaced all missing values coded as question marks with proper NAs. Next, I assigned meaningful column names based on the dataset documentation and converted variables such as price, horsepower, engine size, and fuel efficiency to numeric type. After that, I created two new variables to help our analysis. MPG combined, which combines city and highway fuel economy, and power to weight, which is horsepower divided by curb weight. Once the data was cleaned, I saved the file version as automobile tidy, CSV, and shared it with the rest of the team. This tidy dataset became the foundation for the visualization and modeling on our website. Using the clean data, I then created several scatter plots, each showing a relationship between price and one of them important variables. For example, the price versus horsepower plot shows a clear positive trend. As horsepower increases, car price also increases. You can see it on the right over here. To highlight this relationship, I added regression lines to the plots. These lines make the trend obvious. Cars with larger engines and more power are consistently more expensive. I also visualized price versus combined fuel efficiency, which you can see on the left over here. Here, the regression line slopes downward, showing a negative relationship. Cars with higher MPG values tend to cost less, which reflects the trade-off between performance and economy. These charts and regression models support our project's main conclusion. Performance metrics such as horsepower, engine size, and weight are strong predictors of price, while fuel efficiency is negatively related to price. This is all for tidy dataset charts, parts of the website. So this clean dataset and visual exploration provided the foundation for the predictive modeling that the rest of our group completed. Thank you.
Hi, everyone. So my name is Johanny Branu. I'll be wrapping things up with the conclusion for our project. So as we can see, overall, when we pulled everything together, one thing becomes very clear. Car prices in this dataset are mainly driven by performance features. Bigger engines, higher horsepower, and heavier curb weights all show strong positive relationship with price. Basically, as those features go up, the price goes up right with them. But on the other hand, fuel efficiency moves in the opposite direction. Cars with higher MPG are consistently cheaper, which fits the real world trade off between power and economy. So performance pushes price up, and fuel efficiency tends to bring it down. But when we looked at the regression models, horsepower and engine size stood out as the strongest individual predictor for our price. Fuel efficiency still mattered, but more as a balancing factor that lowers price as mileage improves. These patterns match what we see in the auto industry. So high performance cars cost more, and economical cars fall into lower price tiers. The big picture, this data set shows how performance, efficiency, and design choices shape the car's overall market value. So our results help explain how manufacturers position their vehicles and how customers end up paying for different combinations of power and efficiency. And in conclusion, if someone ever wanted to take this analysis further, they could use models like the decision tree or random forests to capture nonlinear patterns and push the prediction accuracy even higher. Thank you so much.